Thanks very much, Anma. Hi, everyone, and herzlich willkommen. I'm Patrick, as Anma said, and today I'd like to give you an introduction to the Atlassian document format that you're likely to encounter in one of our APIs or webhooks. And let's start with a bit of background on why there is a new format in the first place. We've been rolling out the Atlassian Editor to our products over the last 2 or 3 years. And you quite likely have used the new editor in either Jira, Confluence, Bitbucket, or even Ops Genie. And with the new editor, we're not only shipping a consistent rich text editing experience to our products, we're also shipping a consistent collaboration experience, which means you have elements in the editor, like mentions, that work the same way in all of our products. Or we have code blocks that support line numbers, syntax highlighting, custom indentation rules that are a bit different from the rest of the editor. And as you've heard today in our announcement, we're also contemplating shipping apps that work across all of our products in the editor apps. And if you're curious to learn more about apps, I would encourage you to attend the Forge labs that we're running today and tomorrow all day, and you can try building such an app yourself. We're also continuously adding interactive elements like actions and decisions. Yeah, I have to backtrack here a bit. That was probably a click or two too much. I hope I haven't given away too much in the meantime. But I did speak about mentions, code blocks, apps, and actions and decisions. So those are these interactive elements that allow you to capture tasks or ad hoc decisions right in place in a document. And all of these interactive and rich elements, they need a way to be represented in a document that we can persist in our data stores. How does that work today? We're doing this today in different products. In order to illustrate that, let's look at a simple example, like the one at the bottom here. There's a bit of bold text. There's a code block. Today, we use wiki markup in Jira to persist and represent that. We can do the same in Bitbucket by using Markdown. So pretty similar, not quite the same. And Confluence, that had a rich text editor for a long time, uses CXHTML, which is already a pretty complex format that allows to represent all kinds of content in a document. But what if we wanted to add a new element, say a decision element like we have in the editor? How would we do that in the different products? Wiki markup has no such thing as a decision element, nor does Markdown, and not even CXHTML has an element like that. So that means every single time we want to add new functionality to the editor across the products, we will need to touch 3 different formats in 3 different products at least to do that. And that's something that is time-consuming and error-prone and something we would like to avoid. And that is basically the main reason we're looking at a new format today. It gives us consistency, so we have one format across the products, and it allows for easy extensibility. We have a very clearly defined way of adding new functionality to this format. I can give you a sneak peek into how these 2 examples look like. You don't need to remember much about the format here. We're going to go into much more detail later on. But you can see it's a JSON-based format. You can recognize some nodes. There's some type information in there, text nodes, and so on. And the new elements, this decision element, looks very similar. So same structure, also a type. We're going to, as I said, we're going to go in much more detail. You don't need to remember much from this slide. This is just to give you a bit of an impression of what we're talking about right now. Why did we go for JSON? So for one, it was a bit of a, essentially, decision that was driven by the editor framework that we're using. So we're using an editor framework called ProseMirror. The format that we are seeing here is very similar to the internal format of this editor. But there are many other reasons that speak for JSON. For one, it's a very familiar format. Pretty much anyone has used it before. It's very well supported in different languages, on different stacks, different environments. It's very processable. It's quite likely that you've dealt with JSON when invoking a REST API or processing a webhook somewhere. It's also maintainable for us. So we've built quite a bit of tooling around JSON APIs. So we use JSON schema to validate API payloads, JSON payloads. But we've added functionality to our API toolbox that allows us to, for instance, make decisions on whether two versions of JSON schema are backward or forward compatible as well. And we can use that same tool and apply it to our document format that is JSON-based as well. It's not only, I'm going to stand a bit back, otherwise the same thing happens as before, I think. There are some downsides, of course. Like in all cases, JSON format is relatively verbose. Even if we compare it with CX-HTML, it's maybe about 1.5 times the size when you look at an average document. And it's also not a standard. So JSON is a standard, of course, but the particular format that we're using, that schema, is not something that is used elsewhere a lot. So it's something custom that you have to learn, and that's what we're going to talk about in the next 10-15 minutes. So to look or learn about this document structure, I'm going to use an example that looks like this. So you can recognize 3 paragraphs. And I'm going to use this example to illustrate some core concepts and the core terminology of ADF. You have to remember 3 types of nodes in ADF. That's pretty much all there is, and everything you need to take away from this talk, I guess, is there are 3 types. The first type of node is a block node. And if you want to draw an analogy to browser technology and HTML, you can compare a block node to a div in HTML. It's an element that is full width, flows vertically along your document. Typical examples of block nodes are paragraphs, code blocks, quoted text, or other paragraphs. And block nodes, in some cases, can actually contain other block nodes. A typical example here would be something like a panel that contains a list of paragraphs itself. But more typically, block nodes contain another type of node, which is the inline node. And the analogy of an inline node in the browser world would be a span tag. Span tags flow horizontally, and therewith is dependent on their content. The most common one of the inline nodes is the text node itself, but we have others like mentions or emojis that essentially flow with the text. So these are the 2 main nodes. There's a third one, which is called mark. And a mark is layout information for an inline node. So this is a node that contains information whether a piece of text is bold, for instance, or italic, or a link. And these 3 node types, they make up every single ADF document there is that you can imagine. So let's look at each node type in a bit more detail. And we're starting with the block node here. That's how it looks like in a document. That's the JSON format of a block node. We see there's a type attribute. This is basically just describing what it is. Is it a paragraph? Is it a panel? Is it something else? We often need to store metadata, and we do this in this attrs attribute. That could be, what type of panel is it? Is it an information panel, warning panel, error panel? And block nodes, given that they contain children, need a way to store them as well. That's in this content attribute that we see at the bottom. So those are block nodes. Type and attrs are essentially present on any ADF node. So here, when we look at the next slide, which is the inline node, we recognize the type and the metadata nodes again. They work exactly the same way. So the type would contain, is it a text node, is it emoji, is it something else? But there are 2 additional properties in this particular node. One of them is text. Not surprisingly, it contains the text of text nodes, but it also contains fallback text for other node types. So say we had a new inline node type that is not supported in every version of our products just yet. The renderer of ADF can fall back to this node if it doesn't know how to render it otherwise. And inline nodes also have children, which are these marks that we just talked about that say something about the formatting of a text node. The last one, marks, is even simpler. It's just composed of essentially a type and metadata. That's all there is to marks. So now that we've learned the basics, so these 3 node types and their structure, we can assemble a few example documents to essentially look how this works in practice. And I actually skipped over a particular node type before. It only exists once around the whole rest of it, which is essentially the document root. It has a type as well, which is always doc. It has content like a block node, which contains the children, and it has a version. This version is not something that we're planning to increment. It's a last resort, an exit hatch, if we ever had to make breaking changes to this document format, which is not something that we're planning to do. So let's start here with the first example. We have at the bottom there, you see what we're trying to represent as a ADF document. And so we start with the document around it, and we add a paragraph as essentially the wrapper around the text. You can see that on the right there. Within that paragraph, we add the inline nodes, the text nodes, which is the unformatted sum first. Then we have formatted. And this formatted text also has a mark because we want to mark it as bold. This is what you see in the next transition. And the last one is simply a word again, which is the word content. And this is basically how we would assemble a simple piece of formatted text in ADF by essentially wrapping multiple text nodes in a paragraph if the text nodes are formatted differently. Second example is a panel. A panel is already a block node, so we don't need to wrap it in an extra paragraph. We can just use it as is. And the metadata describes what type of panel it is. So this is an info panel, which means the panel will be rendered with an info icon, as you can see at the bottom. The panel is a block node, has a content node for all the children. In this particular case, we add a paragraph because we want to add some text. And within that paragraph, we add the actual text in the panel. So this is how we would represent this. So there could be also multiple paragraphs for more complex content in that particular panel. Third example is this one. So there's an emoji and a link. Again, we start with a paragraph to wrap the inline nodes. And the 2 inline nodes in this particular case are the emoji first. There's a lot of metadata that describes what type of emoji that is, so what's our internal representation for it. And we see the text attribute here used as the fallback. So we have essentially Unicode emoji as a fallback in case we can't find or render the native emoji that we would otherwise use. There's an empty text node for the space, and there's some more text which will contain the link. And the actual link information, the href attribute, is stored in the metadata in this particular case, in a mark. So we've seen a few examples, and I think at this point you would be actually equipped to create documents in apps that you write. But dealing with raw JSON is not the best experience, typically. So it's pretty verbose, then what was this name of the attribute again, and what are the nesting rules? In order to simplify that, the same team that actually works on the editor within Atlassian has implemented a library that we call ADF utils. It's a TypeScript library that helps you create and parse these ADF documents. And I'm going to show you a few examples of how you would do that. So let's start again with the same example. What if we created this document using the ADF utils library? So the nesting of nodes is represented as nesting of functions or composing of functions in this library. And you would start, for instance, with a doc node. Then you use the paragraph in there, some text nodes, formatted text nodes, add a panel, and nest some more functions along the way. As you can see, this produces the exact same output that we've seen before, but it's just a lot more concise. Not only is it more concise, given that it's TypeScript, you actually get the help from the type system in this particular case. So you would get an error if you get the nesting of types wrong, or if you're missing a required attribute that you're still needing. Creating documents is not everything you will come across when you use our APIs. For instance, when creating a JIRA issue and you need to provide the description, you're quite likely also processing webhooks, for instance, in one of your apps. And in that particular case, you need to process ADF that you receive from our products. And I have an example here as well. And in my example, I want to show you how you could extract all mentions from a document that you receive. In this example documents that I'm using here, these mentions are distributed on different levels. Some of them are nested deeply in some table cells, others are at the top level. So this is a pretty complex document, pretty long, and all these mention nodes are in various places in that document. What's the easiest way to extract all of those? Fortunately, we provide a filter function for this particular case, and the filter function works the following way. So you pass in an ADF node, which is typically a document. You can see that in this first argument there. And the second argument is a function that just makes a decision whether to include that node or not. And in our particular case, our function just says, yeah, I accept all the nodes that are of type mentions, ignore all the rest. So we end up with a list of mention nodes, and we can then use a map function to just extract the ID. If we ran that code on that document that we've seen before, that long one, we would get this result that you see on the right. Sometimes extracting data and traversing documents and extracting data is not quite what you want. You want to traverse a document, but not extract something, but modify something. And the traverse function helps you in doing that. In this particular example, we want to build a very simple linkifier. If you might remember kind of the example with the table before, there was some text in the cells that said like task 1 or task 2, and we want to use that text and turn it into actual links with our code. The traverse function is similar to filter. It also accepts a node as input. Here is the first argument. We're using the document again. And then another function that essentially will be invoked for every text node gets the node and its parent, and it can decide to modify that node. It can do nothing, so returning nothing means the node stays exactly the same. Or I can modify a node and return the new node, and then that will be inserted in that document. So let's look at a small example here. So the document JSON would look like this. There's a text node in there with text task 1. And our code is essentially matching every text node, see if there is text that matches task plus number. If so, we return a copy of the node and add a mark with the link to some hypothetical system that hosts these tasks. So that's a very simple implementation of a linkifier on an ADF document. If you run that, you see the result, same structure, but you get the additional link mark in the result. Rendering documents, something that you might occasionally need as well. If you're using AtlasKit or if you're using React, we have a component for that, which is called the renderer. You can just put a document in it. It will actually render it. Very simple for the simple cases, a bit more involved if you would need support for mentions and similar dynamic attributes. We have a set of other tools and resources that help you with ADF. One of them is the reference documentation itself. So as part of our APIs, we document the node types that are supported by every product. What we're looking at here, for example, is the Jira documentation. You see what node types Jira supports at this time. And you also find examples how they look like in JSON. Within those docs, we offer an ADF builder. That's a tool where you can use the editor. You type the text and format it in any way you want, and you get the ADF output at the bottom. And you can use that as a template, for instance, in your applications. There are a few limits, so we don't support mentions or images there just yet, but for general rich text formatting, you can use that to create templates. Vice versa, we have an ADF viewer that's kind of the opposite direction. You have ADF already that you generated somehow. You put it in that text box, and we render it at the bottom. And you can validate whether it's actually looking the way that you think it should look. Again, similar limits, no image support, smart links are not supported yet, and similar restrictions. All of these examples that I've shown you, the links to these documentation helpers are available online. So that's a Bitbucket repository that contains all of these examples if you want to try it yourself, if you want to run some of those snippets. And with that, I wish you good luck constructing your ADF documents and parsing them. Thank you very much, and enjoy the rest of the day.